long division of polynomials. So in order to do long division with polynomials, we need to think back to probably elementary school, middle school, when we learned to do long division in general. So let's say I have, I don't know, 8,631, and let's divide it by 5. Okay, the first thing we would say is, okay, how many times does 5 go into 8? It goes in once. And then I would multiply 1 times 5 to get 5. Then I would subtract, and I would get 3. And then I would bring down the 6, and I'd do it all over again. 36 divided by 5 is going to give us 7. 7 times 5 is 35. Next thing I would do is subtract, and that gives us a 1. Then I would bring down again, and I would just continue this process. So I'll get a 2, that's 10, subtract, and get 3. And one last time, let's bring it down. That goes in 6 times. 6 times 5 is 30. I would subtract, and I would get a remainder of 1. So we would say that this is our quotient. Up here, our answer. This is our divisor, what we are dividing by. This is our dividend, what's getting divided. And this is our remainder. Okay. So we could write this basically how we would in like a fraction form. We could say this is quotient plus remainder over divisor. And that's how we would make a fraction out of this. So that would be 1,726 plus 1 over 5, or 1,726 and a fifth. Okay? So we can do the same thing with polynomials following the same steps. So if we're going to divide, we're going to put the dividend on the inside. That's 6x squared minus 26x plus 12. We're dividing by x minus 4. Now, what we're really concerned about is that first part, the x. Ignore the minus 4 for now. We'll use it, but we're going to ignore it for now. I want to think, what do I have to multiply x by to turn it into this first term, 6x squared? So x times what is 6x squared? X times 6x. Okay, so that's how many times x goes into 6x squared. Now I'm going to multiply. So I'm really distributing 6x to the x and the minus 4. That's going to give us 6x squared. Good, that'll cancel. And that's a minus 24x. Okay. So I divided, I wrote it, I multiplied. The next thing I'm going to do is subtract. But I'm subtracting the entire blue part there. So when I subtract, signs change. The 6x squareds cancel. That gives me a negative 2x over here. Then I'm going to bring down that plus 12, and I'm going to do it all over again. X goes into negative 2x how many times? That's negative 2 times, and then I'll distribute the negative 2 to the x minus 4. So that's negative 2x, and that is a plus 8. And then lastly, I'm going to subtract. When I subtract, signs change. So I get nothing with the x's. That gives me a 4. So my answer is going to be, oh, no, that's right. My answer is going to be, let's see, 6x minus 2 plus, and then we have 4 as our remainder over x minus 4. Okay. All right, so for the next part, we're going to do the same sort of thing. It's just a little bit messier here. So on the outside, or on the inside, we have 8x to the 4th. Now, notice we skipped the x to the 3rd term. We don't want to skip anything, so we're going to put a 0 as a placeholder. That way we have everything nice and lined up when we go to divide. And on the outside, we have 2x squared minus x plus 2. So again, I'm going to look to that first term, the 2x squared, and I'm going to say 2x squared times what is 8x to the 4th, and that's going to be 4x squared. And then I'm going to multiply everything in the divisor by that 4x squared. So that's going to give us 8x to the 4th minus 4x cubed plus 8x squared. See, now everything's nice and lined up. If I didn't put that 0, then I wouldn't have anywhere for that minus 4x to the 3rd to be sitting. All right, now I'm going to subtract, so change all the signs. The 4th powers cancel. That's 4x cubed minus 2x squared. I'll bring down the minus 3x, and we'll do it all over again. So 2x squared times what is 4x to the third? I have to multiply by 2 and one more x, and then we'll do 2x times the divisor. So that's 4x cubed minus 2x squared plus 4x. Subtract, so change the signs. We get no x cubes. That actually also cancels. So I have 0x squared, which is rather convenient here. That's going to leave me with a minus 7x. There is nothing I can multiply 2x squared by to make it minus 7x because the power is not going to work this way. So I'm done. My answer is going to be the quotient plus the remainder over the divisor. Okay, so it's quotient plus remainder over divisor. All right. Let's see one more. And then I'll show you guys a shortcut. So we have 2x cubed minus 7x squared. We need a placeholder for 0x plus 5. All right. So x goes in. That's 2x squared. We'll multiply out. That's 2x cubed minus 6x squared. And now we'll subtract. So negative x squared. We'll bring down the 0. It's going to go in negative x times. So that's negative x squared plus 3x. Subtract. So we get a minus 3x. We'll bring down that 5. And let's see how many times x goes in. So let's see, we're going to have to multiply by negative 3. That's going to give us negative 3x plus 9. But when I subtract, the signs change. We get a remainder of negative 4. So 2x squared minus x minus 3 plus negative 4 over x minus 3. Okay. All right, synthetic division. So for synthetic division, this is a quicker method, but it only works when we're talking about a linear factor here. All right, so in order to do this, what we need to do is think of what is the factor. So if we have x minus 3, we're going to change that. We're going to use 3 for our number. 3 is going to go on the outside. And then what I want to do from there is write the coefficients. So I have a 2. I have the minus 7. I want to put in a 0 placeholder for the x and a 5. And this is going to be a series of really adding and multiplying. So the first thing I'm going to do is bring down the 2. 2 times 3 is 6. Now I'm going to add these together. That's going to give us negative 1. Then I'm going to multiply. Negative 1 times 3 is negative 3. Add down, I get negative 3. Negative 3 times 3 is negative 9. Add down, I get negative 4. And if you notice, that is the same remainder that we got from this problem up here. 2, negative 1, negative 3, with a remainder of negative 4. Okay, so this lets us do the same problem just a little bit quicker. So we have a remainder of negative 4. This just drops a degree, so this is a 2x squared minus 1x minus 3 with a remainder of negative 4. Let's try this again, just a different problem. So this is going to change sign and make it a 3 on the outside. We have a 1 coefficient, negative 9, 27 minus 27. Bring down the 1. And now it's multiply, add, till we get to the end. 1 times 3 is 3. Add, get negative 6. Negative 6 times 3 is negative 18. We're going to add and get 9. 9 times 3 is 27. Add and get 0. That means our remainder is 0, and it went in nicely. So we have, let's see, drop a degree. So that's squared. 1x squared minus 6x plus 9 with a remainder of 0. So this is it. No remainder whatsoever. It went in nicely. And this is going to help us to factor. So really, we're kind of headed that direction. We can say that x cubed minus 9x squared plus 27x minus 27 is equal to x minus 3, what we were dividing by, times what we got. And then we'll be able to continue factoring from there, and it's going to help us to find our zeros to then graph. All right, so one more. Let's see, we're going to change that sign to a 6. We have a 3, a 5. Don't forget a placeholder for that constant at the end. Bring down the 3 and multiply. Add. That's going to give us 23. Multiply 138 and add, we're going to get 138. That means we have drop a degree, so squared becomes first power. 3x plus 23 with a remainder of 138. So we have 3x plus 23 with a remainder of 138. So that's plus 138 over the factor, or the factor. All right, let's see one more. So we have a negative 2. We're going to change that to 1, 2, 2, 1. We didn't skip anything. That went third power, second power, first power, no x's. Bring down the 1, multiply, add, multiply, add, multiply, add. Here's my remainder. So I have x squared plus 0x plus 2 with a remainder of negative 3. So that's x squared plus 2 plus negative 3 over x plus 2. Okay. When the remainder is 0, that's really what's going to benefit us as we continue working through these types of problems.